Good evening everybody. My name is Krupal Patel. I am from India. So today I am going to talk about little bit about batteries, but I will start with the history of battery. So in 1800, Volta invented first battery which is based on chemical reaction. So this is voltaic pile, which is called as voltaic pile. So you can visit the Volta temple in Como, Italy if you are free this summer, and see this cool first initial battery. So it is made up of zinc and copper disc, and it is separated by electrolyte, which is soaked cardboard paper or cloth soaked in brine, and then from that point onwards we have different cells: Daniel cell, Bird cell, porous port cell, gravity cell, Pog and drop cell, groove cell and Dunn cell. But fast forward to modern day batteries. So the discovery of rechargeable lithium-ion battery started with 1912 by Gilbert and Lewis, which was American inventor. Then in 1980s, John B. Goodenough at Oxford University invented lithium cobalt oxide as a cathode, and at the same time Rashid Yazami, from Moroccan scientist, invented graphite anode. These two inventions led to the first battery prototype by Akira Yoshino of Japan to build first prototype of lithium-ion battery in 1985. Then that point onwards, Sony commercialized lithium-ion batteries in 1991, and in 2019 John B. Goodenough and Akira Yoshino won the Nobel Prize for their inventions. So this is discovery of rechargeable lithium-ion batteries. But how does battery works? So this is simple animation of how lithium-ion battery works. So there are four parts to it: cathode, anode, separator and electrolyte. So as you can see, when you charge the battery, the lithium ion moves from cathode to anode. It is only through electrolyte, and when you discharge the battery, it moves from anode to cathode. So this is how lithium-ion battery works, and we see typical use cases of battery. So it is used in electric vehicles, your mobile phone, portable devices. It can be used as energy storage devices. So as you have seen the earlier talk where we need storage devices to store a lot of energy in future, because we are moving towards electrification of our grids. So why lithium-ion batteries are popular? So as you can see from this graph, the specific energy density and volumetric energy density is very high for lithium-ion batteries. So you can store the charge within small volume, and you can have high energy density for lighter weight application. It is having long lifespan, fast charging, and it is versatile. However, there are few problems. So you have seen in current news papers or news channel that the batteries are getting fired, and that is unsafe. This is happening because we are using liquid electrolyte, which is flammable. So as we want to move towards safer operation of batteries and more energy dense batteries, we need something else than liquid electrolyte. So can we use solid electrolyte instead of liquid electrolyte in lithium-ion batteries? Yes, we can use. So in between 1831 and 1834, Michael Faraday started working with solid state ionics, and he laid the foundation for solid state ionics. So we can use solid electrolyte. However, there are problems with solid electrolyte. As you can see from these images, when there is no charging discharging cycle, the first image shows the pristine state of anode and solid electrolyte. After several discharge cycle, void nucleates at the interface of anode and the solid electrolyte, and because of void, in the corner of the void there is large current which is passing through from anode to solid electrolyte, and because of that, after several plating cycles, the dendrite grows from anode to cathode and it short circuits the battery. Basically, dendrites are made up of lithium itself, and because of that it is not commercialized yet. So, we need to solve this problem. So, we can take inspiration from cavity formation in soft adhesives. So, as you can see, the cavity, the soft adhesive layer is sandwiched between steep substrate and the steep backing, and when you pull the tape from the substrate, cavity nucleates in the adhesive layers, and this is the cavitation problem which is going on in Scotch tape, and we can take this example as a starting point to solve the cavitation problem to solve the voiding problem in batteries. So, what is our hypothesis for voiding problem? So, lithium is soft viscoplastic material and it is subjected to large electric field at the interface of anode and the solid electrolyte. Because of that, pressure builds up, and because it is incompressible, it cannot have, so energetically favorable way of deformation is cavity nucleation. Because of that, cavity nucleates. So, we can change the surface energy of the material and solve this problem. So, this is our hypothesis for our voiding problem, and to showcase the commercial side of this solid state battery market, it is about to grow by 38.75% compounded annual growth rate from 2024 to 2032. So, it is going to be a large market, but before that we need to solve these problems of dendrite and voiding. I am happy to take questions on this. Thank you.